Hi there, and welcome to this lesson on Pure Mathematics 2. In this lesson, we're on Chapter 2, 2.2, and we're looking at the equation of a circle. Now, if you've got a circle with center AB and radius R, then the equation of that circle is x minus a squared plus y minus b squared is equal to r squared. And in the special case where the center is the origin, then a and b are both equal to 0, and you'd get the circle x squared plus y squared equals r squared. Now we're going to go straight into some examples in this lesson. So there's the equation of a circle, center AB, radius r. Write the equation of the circle with center 4 minus 3 and radius 5. Then part 2, different circle. Given the circle with equation x minus 2 squared plus y minus 8 squared equals 7 squared, find the center and radius of that circle. And then part 3, a different circle again. Given the circle with equation x plus 5 squared plus y minus 11 squared minus 81 equals 0, again find the center and radius of that circle. Very little is happening on these questions. All we're doing is using this basic definition of a circle. What I'll do for each question is write down what A is, write down what B is, write down what R is, and then write down what they asked me to find. Okay, I'll let you have a go at doing all of that for these 3 questions. So pause the video, have a go, and then come back to me when you're ready. Okay, let's have a look. So question 1 asks us to write the equation of the circle where we're told the center, it's 4 minus 3, and we're told the radius is 5. So in this question, A is equal to 4, B is equal to minus 3. You do have to be careful with signs with these questions. And R, the radius, is equal to 5. All we have to do is substitute those values into the equation. And that gives us that the equation of the circle is x minus 4 squared plus y plus 3 squared equals 5 squared, or 25. Question 2 is the other way around. They give us the equation of the circle and ask us to find the center and radius. But again, just to make it absolutely clear, I'll write down what A, B, and R are. So A is 2 in this question, B is 8, and R is 7. Just remember that it's minus in the brackets in the equation, which means minus is what we want. So A is just 2, B is just 8. And that means that the center of the circle is 2, 8, and the radius of the circle is 7. Now, part 3, exactly the same idea, but a little bit more work for you to do. So if they don't write the equation in the standard form of the circle, you may need to do a little bit of work to change it into the standard form. So the first thing I would do is move the 81 to the other side, and then square root it, so I've got 9 squared. Having done that, we can then say A is minus 5 from this first bracket, B is equal to plus 11 from the second one, R is equal to 9, and again we can just write down the center and radius. The center is minus 5, 11, the radius is 9. Okay, example 2. And you're given an equation of a circle, x minus 3 squared plus y minus 9 squared equals 10 squared. And then what you're asked is whether these 2 points are on the circumference of that circle. So whether the circle passes through those points. Now the idea here is the same as for any equation. If you want to know whether a point is on a given curve, you substitute the point in and you see if it works. So we'll substitute x equals 10, y equals 16 into this equation, work out the answer. If we get 100 for the answer, 10 squared, yes, the point's on the circle. If we don't get 100, no, the point isn't on the circle. Okay, I'll let you have a go at doing that for both of these 2 questions. Pause the video, come back when you're ready. Okay, let's have a look. So the first point is 10, 16. Well, the point 10, 16 is the point where x equals 10 and y equals 16. So those are the values of x and y that we need to substitute into the equation of the circle. So if I substitute x equals 10 and y equals 16 in, that's what I'll get on the left-hand side. 10 minus 3 is 7, 16 minus 9 is also 7. So we get 7 squared plus 7 squared, which is 49 plus 49, which gives me 98 for the answer. What did I want to get for the answer? I wanted to get 100, 10 squared. Now, if I got 100 for the answer, that would mean that this point is on the circle. It's on the circumference of the circle. I nearly got 100, but I didn't. So 98 doesn't equal 10 squared. It doesn't equal 100. Therefore, the circle does not pass through the point P 10, 16. What about the second point? We do exactly the same thing. So now we've got x equals 9 and y equals 17. So we substitute that into the equation. 9 minus 3 is 6. 17 minus 9 is 8. So that gives us 6 squared plus 8 squared, which is 36 plus 64, which is exactly 100. 100 does equal 10 squared. Therefore, the circle does pass through the point Q 917. 917 will be on the circumference of the circle. Okay, sample 3, a little bit different, a little bit more work on this question. We've got a circle, and we've been given the endpoints of the diameter of the circle. So the diameter of the circle, or one of the diameters, will have endpoints 4, 3, and -2, -5. But that's all we're told. From that information, we have to work out what the equation of the circle is. Well, to work out the equation of the circle, we need to know two things. We need to know the center of the circle, AB. We need to know the radius of the circle. The way I'll do this is in two parts. First of all, if those are the end points of the diameter, that means I can work out the length of the diameter in the normal way using Pythagoras. The square root of the difference in the x value squared plus the difference in the y value squared. Hopefully you remember the formula. So I'll use that formula to work out the length of AB. That'll be the diameter. Half that, I'll have the radius. So I'll have R. And then to find AB, we'll be using what we used in the last lesson. The center of the circle is the midpoint of the diameter. So it's the middle of these 2 points. So I'll find the average of the x values, the average of the y values. That'll give me the center of the circle. Then I can write down the equation of the circle. Okay, I hope that made some sense. Anyway, I'll let you have a go at doing it first. So pause the video, have a go, and then come back to me as soon as you're ready. Okay, let's have a look at this. So first thing I'm going to do is find the length of diameter. And that's the formula for finding the length of any line segment. So you square the difference in the x values, square the difference in the y values, add them together, square rooted. That is just Pythagoras' theorem, really. So putting in x2 and x1, we've got 4 take away -2 for the x values, 3 take away -5 for the y values. That tidies up to that, which gives us the square root of 6 squared plus 8 squared, same as we had in the last question. That'll give us the square root of 36 plus 64, which is root 100, which is 10. So 10 is the diameter of the circle, the length from A to B. That means the radius will be half of that. So the radius is 5. We've worked out R, now we need to work out the center of the circle. So that's what we've done so far. The center of the circle is the midpoint of AB, which is the average of the 2 x coordinates and the average of the 2 y coordinates. So that gives me 4 plus -2 divided by 2 and 3 plus -5 divided by 2. That tidies up to that, which gives me 2 over 2 and -2 over 2, which gives me 1 minus 1 for the center of the circle. So I now know the center of the circle. The center is 1 minus 1. I know the radius. The radius is 5. Therefore, the equation of the circle is x minus 1 squared plus y plus 1 squared. Be careful with the minus 1 there for the y coordinate, is equal to 5 squared. And that's the answer. Okay, a circle, center AB and radius R. We've already said that that's the neatest way of writing down the equation of the circle, because you can see the center and you can see the radius from the formula. But there is a second form, which is also used for the equation of a circle, that's derived from multiplying out the brackets in the first form. Now, the truth is, I'm not a big fan of the second form. I never use it unless I have to. But there are some questions where you have to, because they ask you to. So we will look at it. So going back to the normal definition of a circle, we multiply out the brackets. Squaring these two brackets will give me that. Then I'm just going to collect up terms. So I've got the x squared and the y squared first. I've then got the x's, then the y's, and then the constant term I've tidied up here. And these last three terms, the coefficients are just tidied up into a neater form. So rather than minus 2ax, they write it as plus 2fx. Rather than minus 2ay, they write it as plus 2gy. And the whole of this squared bracket here, they just write as c. And this is the standard notation for the second form of the circle. X squared plus y squared plus 2fx plus 2gy plus c equals 0 is always a circle. We're just comparing these together. A is minus f, b is minus g, and r, the radius of the circle, will be the square root of f squared plus g squared minus c. What this gives you is a circle with center minus f minus g, if it's written in this form, and radius r equals the square root of f squared plus g squared minus c. Now, it feels a lot more clumsy, that, but there are questions where they ask you to use this form, and presumably there are questions where it's more helpful to use this form. But as I say, personally, I find questions easier if I convert from this form back into the original form. And that is what I would tend to do, unless there's an extremely good reason for not doing so. Let's have a look at an example doing all of this. So there's the standard notation for the equation of a circle, and then there's the second form there, where the center would be minus f minus g, if it was written like that, and the radius would be the square root of f squared plus g squared minus c. And the example gives us an equation in that form. And it asks us to find the center and the radius of the circle with that equation. Now, what I suggest you do is try using both methods. So the quickest way is probably to use the second form, because they've written it like the second form. So have a go at using the second form just to write down what the center and radius are. But also have a go at converting this back into the standard form and getting the center and radius from that. So try both methods. Pause the video, and then come back to me as soon as you're ready. Okay, let's have a look. Now, what I'm going to do is convert it into the standard form first. So x squared plus 12x plus y squared minus 18y equals 33, just rearranging that a little bit. And then I'm going to get these squared brackets. So x squared plus 12x is x plus 6 squared. That'll give me the x squared. It'll give me 6x twice, so it gives me 12x. It also gives me 6 times 6. So it'll also give me 36, which I don't want, which is why I've got the minus 36 there. Then doing the same with the y terms, y squared minus 18y is y minus 9 squared. That'll give me the y squared. It'll give me 2 lots of minus 9y. That gives me the minus 18y I want. It also gives me 9 squared, 9 times 9. So it gives me 81 that I don't want, which is why I've taken away the 81. Then moving all the constants to the other side gives me that. Tidying it up gives me that. And then you can read the center and radius from that. So the center of the circle will be minus 6, 9 in the normal way. And the radius will be the square root of 150. Make sure you remember to do that. And the square root of 150 is 5 root 6. That's probably the longer way of doing it. The shorter way is if you are familiar with the second form for a circle. So note, in this question, all you have to do is halve the number of x's, halve the number of y's, and you c equals minus 33. And then the center will be minus f minus g, and the radius will be all of that. So in this question, f is 6, g is minus 9, the center will be 6 minus 6, 9. And the radius will be the square root of 6 squared plus minus 9 squared plus 33, which is 5 root 6. So that's how you get the answer using the second form. But as I say, my inclination is certainly to use the first form if I can do, and to only use the second form if I really can't do, or if the question strongly says I shouldn't do, that they're expecting to see that. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 31 and have a go at exercise 2C. Thank you very much for listening, and cheerio.